flexible AC power systems, economic operation of power system, automatic control model, auto reduction, and distributed generation. Please, sir.
Okay, thank you.
Sir, please share your slides.
Okay, I will share.
Sir. Post.
You have disabled. Now I've changed my name, Professor Dr. Siddharth Panna. Okay. Host disabled participants screen sharing.
Sir, we have named your screen.
Okay.
Sir, please share now. So now it is here.
Okay, is it visible to all?
Yes, sir, visible, sir.
Okay. Okay, we will start then.
Yes, sir.
So, good morning, all. So, today I am going to present about the soft computing applications, specifically to engineering problems. Okay. So, there we will take one problem and we will apply a soft computing technique, and later on we will discuss the other techniques also, and so that those techniques also can be applied to the same any problems. Now what is soft computing? To understand the soft computing, first you need to understand what is hard computing. So hard computing or conventional computing. Okay. Hard computing or conventional computing. So that requires a precisely stated analytical models. So that is some mathematical terms. So, and often hard computing requires a lot of computational times. So let us take a simple problem. So like say find the minimum of function f of x, which is equal to x square . Okay. In between, am I audible? No? Okay. Hello?
Yes, sir, audible, sir.
Okay. Because
sir, your video is not coming, sir.
Video is not coming? Just I will see again.
Yes, sir.
Computing.
Participant was
Wait from my system, then I will join. Okay.
have to at least.
Is it coming now?
Yes, sir.
Coming now? Okay. Okay. So hard computing, that means finding the say minimum of a function. Let us take a simple function. F of x is equal to x square minus 2x plus 10. Say. So conventional computing or hard computing, how to solve this problem? So we find the derivative of function and equate that to 0. So derivative of function will be 2x minus 2, and if you solve that one, we'll get x is equal to 1. So you can check also. So f of 1, if you use 1, the objective function value will be now 9. Okay. If you take other value like 2, 3 or 0, minus 1, so you are getting more than that value. No, 9 is the minimum value you are getting. In other case, 10, 13 or 10, 13 like this you are getting. So even 0.9 or 0.99 also you are getting more than that value. So above 9 you are getting. So, but practical, so this is an easy problem where you can find the derivative of the functions. But practical problems are more complex and constrained. Constraint means in a particular range only you have to search. Like say x should be searched in a range 0 to 20. And the function contains some sign terms and cost terms, like say 5 plus x by 20 plus 5 sine 8x, like this. It is a complex. So if you plot f of x versus x, you will see that it will have many maxima and minima. So this type of problem, you cannot apply our earlier method of finding the derivative of the function and equate that to 0, because there will be many maxima and minima. So how to solve this type of practical problems, which are complex and constraints? So one approach is exhaustive search. Exhaustive search means you take all possible values of x. So first value is 0. Next value is depending on precision. Suppose precision is 10 to power minus 4. That means next value is 0.0001. Then 0.0002. So like this, you should go on increasing the x value and test f of x value until you reach 20. So that means probably you have to repeat 2 lakh times. So it is very difficult, no, time consuming. Other option is application of soft computing technique. So by applying this soft computing technique in a very short time, most likely you will get the answers. Okay. So the difference between hard computing and soft computing is that the problem in hard computing, the problem formulation must satisfy mathematical restrictions. Like there, we are finding the derivative of that function. So if the function is not derivatable, then it will create a problem. And hard computing is a single point search, and it is heavy computational burden, and slowly it will converge. But in case of soft computing technique, there is no mathematical restrictions. So even if the function is not, you cannot find the derivative of that function, still you can find the say maxima or minima of that function. Then it is a multi-point search, whereas hard computing is a single point search. Like search technique, like suppose you have dropped a coin in a room. Single point search means only one person is engaged to search that coin. So if it is a big room, it will take so much time. No, multi-point search means many people are engaged to do that search. So most likely you will reach the goal. No? You will get you will find the coin if more people are involved. So that is multiple. So initially only in soft computing technique, a set of points will be taken, a set of solutions. So soft computing is easy to implement, numerically robust, and may find a global optimum. Now that is the problem here. It will not guarantee that you will get the global optimum. You may or may not find the global optimum, but in most cases you will find the global optimum value, and it can produce alternative solutions also. This final solution, a set of solution it will give. So depending that one, we can, depending on our requirement, we can proceed. Now coming to soft computing. So soft computing is not a single technique, and it is not yet precisely defined. No, artificial intelligence techniques, soft computing technique, heuristic techniques. So different name we are using, say. So the definition was proposed by the inventor of fuzzy logic, no, L.A. Jedi. That is, soft computing is a collection of methodologies that aims to exploit the tolerance of imprecision and uncertainty to achieve traceability, robustness, and low solution cost. So strictly speaking, it is a collection of methods. It is not a single technique. Many methods are combining, they are known as the soft computing techniques. They are useful because the soft computing techniques have been applied to many real world problem of late, like say, be it in any field, like say signal processing, pattern recognition, business, forecasting, and speech processing. So you name any problem, so there is a scope to apply the soft computing technique to improve or to get the better performance. Either in say reduced time you will get the solution, or in other approach you will not get the solution, but if you apply the soft computing technique, you may get a solution. So there is some benefit of this one. So hard computing requires a precisely stated analytical model and often lot of computational time, whereas soft computing does not require a mathematical models and requires less times. So hard computing is based on binary logic, yes or no, like this one, crisp values and numerical analysis. Soft computing is based on fuzzy logic or neural network or probabilistic reasonings. And hard computing has the characteristics of precision, but soft computing has the characteristics of approximations. Okay. And hard computing requires programs to be written, and soft computing can evolve in its own. So hard computing means that it will follow the same path always. If you apply 100 times, you will get the same solution. But soft computing, depending on the nature of that soft computing, because there are many soft computing techniques. So depending on the which technique you have employed, it will evolve. Okay, it will not follow the same path always. So depending on the problem, or depending on the solution, and depending on the algorithm, we will reach the final solutions. So again, some comparison. Okay. Now, what is soft computing techniques? Soft computing technique. Okay. So this is, let us define the soft computing technique as getting the computers to do the task which requires intelligence. So what is intelligence? And if you define intelligence, sometimes simple things turn out to be hardest to computerize, like say recognizing a face. No, I will use this one. Someone they are admitting. Okay. Recognizing a face or navigating a busy street, understanding what someone to say. So for example, recognizing a face, if you say, so when you see the face of your say any friends or relatives, so immediately you can recognize. But how to write a program so that you will extract some features of that say face, and if you feed those features, then it will identify that, okay, this is that person. So what I want to say here is, sometimes even if it is simple things, very difficult to write the program for that one. Okay. So this task requires reasoning on knowledge. But the study and development of soft computing techniques that requires, we should think and reason like a biological systems. Think and reason rationally, act like biological system, and act rationally. So the objective is to understand intelligence better and to test theories of intelligence by writing programs which emulate it. So all the soft computing techniques, more or less, they are based on the biological systems, because biological systems, they are endowed with the ability to learn and adapt appropriately in any unknown environment and act successfully towards its goals. So any biological system, if you keep the biological system in any environment, so it will adapt, it will learn and adapt. No, all of us, we have heard about the Tarzans. No, if a boy is left in a jungle, so he will try to learn and adapt to that environment, and most likely he will survive that one. That means he will reach its goal. Okay. Okay. Now this soft computing techniques depends many disciplines, like say computer science, psychology, because you have to think like humans, human reasoning, philosophy, linguistic. No, you have to put those reasoning into words. Then human biology. So soft computing techniques draws ideas from each disciplines. Next. Now, soft computing techniques consist of several computing paradigms, and they are evolutionary computing, fuzzy computing, and neurocomputing. But all these methods have something in common. What is that? They are nonlinear, and they have the ability to deal with nonlinearities, follow some reasoning part than the classical methods, and they utilize self-learning. So automatically they will learn and adapt and evolve. And sometimes they utilize yet to be proven theorems. Some theorems are not yet proved, and you can utilize those theorems to find your solutions. But soft computing technique is still growing and developing. So various dimensions of inspirations based on which the soft computing techniques have been developed: the mind, brain, and genes. Okay. So mind, based on the mind, the physiologic system works. Like say, if temperature is hot and humidity is wet, then you put the fan speed in high condition. So depending on this if-then rule, the physiologic works. Similarly, based on the brain areas, the neural network works. So if you give some input, it will process those inputs and give us the output. And from the optimization technique, we started with the genetic algorithm, which are based on the genes. Okay. So based on genes, the genetic algorithm has been evolved. Okay. So we'll start with some optimization techniques. Okay. Evolutionary computation. So evolutionary computing techniques. So there are many techniques like genetic algorithm, particle swarm optimization, differential evolution. So these are all optimization techniques. which comes under the category of evolutionary computing techniques. So they are promising algorithm for handling optimization problem. Optimization means either you want to minimize something or maximize something. And modern optimization techniques are finding popularity within the research community as design tool and problem solvers, because all are population based search algorithm and they are versatile. No, so you can fit the program to your problem. So no need to write the program again. Simply what is your objective, you specify and link that problem to your objective. So that we will take a simple problem also today and we will see. So for example, in the MATLAB, there is a genetic algorithm toolbox. So already a program optimization routines are written there. So how to use those say written program for our problem? So only you have to specify what is your problem and how many variables are there. Then you can utilize that problem. So it is versatile. No. And it is, I got the ability to optimize complex multimodal search process, and it can be applied to non-differentiable objective functions. So all the subcomputing techniques can be applied to this non-differentiable. But hard computing means you have to first differentiate, then find the optimization. So if you see the list of techniques, there are many techniques. No, every day one new technique is coming up. So there are some hundreds optimization techniques are there, but it started with the genetic algorithm. Then the particle sum optimization, differential evolution, ant colony optimization. So I have named some technique only, but it is still growing. Okay. Now let us take a problem. That same problem which what we had discussed in the initially during the initial stages of our presentations. So find the minimum of any function f of x, where f of x is equal to 5 plus x by 20 and some sine term and some cosine terms are there. So as I said, if you do the exhaustive search with a precision of 10 to the power minus 4, then you have to repeat 2 lakh times. So other approach is a blind generate and test. So blindly, what is that one? You generate a random possible solution. You randomly you take any value from 0 to 20 and find f of x. Okay. Then you modify the solution. That means suppose initially you have taken x is equal to 2. Then you find what is f of x. Then modify this, instead of 2, you use say 4. Then find f of x. So whether 2 is better or 4 is better. Okay. Then you find a new solution. Modify the solution and repeat until the solution is good enough. So this is one some say first stage. But it is also difficult, no? How to modify the solution and how do you know what is the good solutions? That is the problems. That means whether it will work, can you use this dumb idea? Sometimes yes, because if there are only a few possible solutions and if you have enough time, but nowadays nobody is having time. So that means in most cases you cannot apply that once. Okay, because you don't have time to try all the solutions. And many practical objective functions or problems are non-differentiable, non-continuous, non-linear, no mathematical expressions. Okay, so how to handle this one? So that dumb idea is like this one. Initially, suppose we generate a set of solution. Remember that x is allowed to vary from say in a range. So you create some set of random solutions. Say 2, 5, 8, -1 and -4. These are possible x. And find out f of x for each case. Then test the solution. You will see that the values are coming as 10, 25, 58, 13 and 34. Then you arrange that. Okay. What is the best one or worst to best? The third one is the worst. No, f of 8 is equal to 58. because your objective is to find the minimum. The minimum value is coming as 10. The first solution is the minimum. Okay, so first we generate a set of solutions, and second we rank the solution. So arrange them in worst to best. So the worst one is third one, next is fifth, next second, fourth, and first, like this. Then remove the bad solution from the set. So bad solution means third and fifth you remove. Okay, that means 8 and minus 4. And modify some best solution. Best solutions are first and fourth. How to modify? Let us take the average of that one. Say. So you have taken 2 as first and minus 1 as the fourth. So average of that one is 2 plus minus 1 by 2.5. Then find out what is f of x. You will see that now f of x is still less than those previous values, 9.25, something it is coming. So like this you can repeat. So based on this type of idea, the genetic algorithm works. So it creates a set of random population, then it tests the fitness of those forms, say how good the solutions are. Then applying some genetic algorithm concept, it will modify the solutions and it will create the new solutions. So this is about the genetic algorithm. So genetic algorithm is developed by John Holland in 70s and it got popular in late 80s. And it is based on loosely on Darwin's principle of biological evolution, reproduction, and the survival of the fittest. Who is fit, he will survive. No, those who are not fit, they will not survive. That means, like our previous case, if the solutions are bad solutions, you remove that one. So they are not surviving. So who are fit, they will survive. So genetic algorithm maintains a set of candidate solutions, and that is known as population, and repeatedly modifies them. And GA selects good individuals from the current population. Good individuals are chosen as parents and use them to produce the children for the next generation. So like our genetic algorithm on human say, development, it is best. You might have seen if father and mother are doctor, most likely their son or daughter will be the doctor. Say. He will be of good standard, most of the cases. But sometimes, even though father and mother are illiterate, sometimes the child will be very brilliant. So, but it rarely occurs, but it also occurs. So all these concepts are taken into this genetic algorithm. There it will select good solutions and produce the better solutions, as well as there is a strategy known as mutation, where randomly it will change the one solution to get the better solutions. We will see this one. Okay. So the scheme of GA. So in fact, all optimization techniques, somehow they will follow these steps. So the first is same for all. Whatever technique you are using, whether it is genetic algorithm or say PSO or differential evaluation or GWO, any technique if you take, first step is initial population generation. So it will generate a set of initial population, and all the techniques follow the second, the fitness function evaluation. So they will check how good the solutions are. So second step is the fitness function evaluation. Next, this is specifically for GA only. Then the selection. Okay. So good solutions are chosen by using some approach. Then they will apply the two operator. One is crossover operator and second one is mutation operator. So by applying this one, they will create the child or offspring and will enter into the new generations. Okay. So some issues, again these issues will be applicable to any technique. Whatever technique you apply, you have to address these issues, like solution representation, how to represent the solutions. So you can represent by using binary or floating point, integer or real number, and then initialization. How to do the create or generate the initial solution. In most of the cases, it is generated or created randomly. Other is you can use from other heuristic. From other method, you generate the initial conditions or use follow some current practice. Okay. Then in case of GA, the selection function, it is a probabilistic. Okay. So probabilistic means the you will use such a method that the probability of getting good solutions is more. Probability. So that means there is a probability, less probability of getting bad solutions also. Okay. So here we follow generally the roulette wheel, linear linking, or geometric ranking, etc. Then the genetic operator, the crossover and mutation. Again, crossover can be simple or arithmetic or heuristic. Similarly, mutation can be uniform, non-uniform, or various schemes are there. And termination. So any technique, again, this is applicable to all the techniques, terminations. So that is the stopping criteria. So generally, the number of generations will be a stopping criteria. That means after a particular number of generations, say 100 or 500 or 1000, the algorithm will stop. Because any algorithm, they do not know when to stop. No, you have to specify that one. Or you can say when all the solutions converge, or when the target value is achieved, or if there is no improvement. So you have to specify at the beginning when to stop. Okay. So GA begins by creating a random initial population, and GA uses the individual in the current generation to create the next population by the following steps. So we will take a problem, then it will be more clear. Okay. These are some of the terms, stopping conditions. No, generation, time limit, fitness limit, stall generation, stall time. Okay. So when to stop? Okay. Now some terms, again, some genetic algorithm terminology. So again, these terminologies will be used in all the optimization techniques. The fitness functions. So fitness function is, this is the function which we want to optimize. Optimize means either minimize or maximize. So sometimes it is also known as objective function, or in some cases it is known as cost functions. So cost function, fitness function, objective functions, all are same in any optimization technique. So that is that function you want to minimize or maximize. Okay. So you use the term optimize. Suppose your objective is to, you are doing business and you find the, say, profit. So you want to optimize the profit. That means you want to maximize the profit. Or if your objective is, say, objective function is expressed as loss, say, so you want to minimize the loss. So optimize means either minimize or maximize depending on our requirements. So all the objective functions, all the optimization techniques, they will try to find the minimum of the fitness function, and sometimes you can change that one. Then individuals, these are some terms. So an individual is any point to which you can apply the fitness function, and the value of fitness function or individual is known as its scores. And the population, what is population? So population is an array of individuals. No, for example, if the size of population is 100 and the number of variables in the fitness function is 3, so then you can represent the population by a 100 by 3 matrix. Okay. Next term is the generation. So at each iteration, the genetic algorithm performs a series of computations. Similarly, in other technique also, if you apply PS also, so it will apply a series of computations on the current population and to produce a new population. So each successive population is called a new generation, or sometimes it is called iteration, new generation or new iterations. Next term is the fitness value. So the fitness value of an individual is the value of fitness function for that individual, and population is an array of individuals. So that means how fit the solutions are. So first step is you are generating random solutions. Then you are testing how good the solutions are. How good the solution means using that objective function you are finding whether they are fit or not. So that is known as the fitness value. And the best fitness value, and similarly parent and children. Like this, these terms are used. Okay, we have taken again one example from the Goldberg. So we have taken a simple problem. Find the maximum of x square over 0 to 31. So if you want to apply GA approach, you represent first. If you are using binary code, 5 bits are required. No, if you use the 4 bits up to 15 only, you can represent. Because your range is 31, so you have to use the 5 bit. So if it is 1 1 1 1 1, then up to this 31 you can represent. So population size is in our hand. You can use any population size. Let us take 4. So initialization means randomly you will generate 4 solutions between that range. The range is 0 to 31. So let us say solutions are, say, initially randomly you have generated 13, 24, 8 and 19. Say. Okay. Like this you have generated. Then we will apply some operators and selection and termination. Say. Okay. The process is like this one. So those 4 values we have generated initially, 13. So that is represented by binary 0, 1, 1, 0, 1. Similarly 24, 8 and 19. Then we find the fitness value. Fitness value means f of x is equal to x square. So if x is equal to 13, f of x is equal to 169. If it is 24, 576. Like this, the values we are calculating. Then we are assigning the number. In the last column, we have written 1, 2, 3, 4 or 2, 4, 1, 3. So 4 is the worst one. One is, so we are arranging from low to high value. So low value is 64. So that is assigned value 1. Then 2, 169, 3, 361. Like this, we are applying. Okay. In the next case, you take those good solutions and create some offsprings. So from that, we are getting the value of say like 13 and 25. So like this, how it is generated. So you are taking P1 and P2, and you are creating the 2 childs, C1 and C2. Okay. Yes.
Slide गुड़ा पढ़ुची.
Yes, somebody else was talking. Okay. So anyway, let us take a problem, then it will be more interesting to you. Okay. So fortunately, you need not write this problem, all these terms, whatever I said, but you should understand what is fitness function, what is initial population. Okay. So because there are many application toolboxes in MATLAB. If you are using MATLAB, there are many application toolboxes, and there is a toolbox known as the global optimization toolbox. There, this global optimization toolbox provides methods that search for global solutions for problems that contain multiple maxima or minima. Like this complex problem, any problem we can apply that toolbox. Toolbox means it is a collection of functions. So already, like as I said, genetic algorithm. For genetic algorithm, the programs are already written and stored there. Simply you have to utilize that one. So even that have some default parameters, like so what should be the population, what should be the generation, what should be the stopping criteria. So already default parameters are specified. If you want, you can change. Otherwise, simply you can use those default value to run any problems. Okay. So there are many. It includes the global search, multi-start, pattern search, like genetic algorithm or simulated learning. So all these techniques are available in that global optimization toolbox, and you can apply this for any optimization problem. Optimization means either minimization or maximization. And for controller design, you can do model reduction, tuning, and many other problems you can apply. So how to use that ones, the existing GA? It will be easy to start with. So you can run the genetic algorithm with default options. Default option means all the parameters. Parameter means what should be the population size, what is the crossover operation, what is the mutation operation, what is the stopping criteria. So everything is specified for a default option. If you want, later you can change that one. So anyway, to run the genetic algorithm with default options, you have to call the GA with syntax in the bracket X, F value is equal to GA with a fixed fitness handle and fitness function and n bars. Okay. So we'll take one example, then it will be more clear. So what are the arguments? Input arguments are the fitness functions with a function handle. So a function handle to the file that computes the fitness function. So how the fitness function means? That means the MATLAB expression of our objective you have to write, and n bars is the number of independent variables. So these are the inputs. Output is the x, the final solution or the final point, and x f value is the value of fitness function at x. Okay. So directly we will take a problem, then it will be more clear. Say, okay, here say. Example is so one variable. Again, the same problem. Let us take say f of x is equal to that 5 plus x by 20 and sine term and cosine terms are there. Say. So first thing is you solution. You see, create an M file and save that using some unique name. Unique name means because there are many functions written and saved in the MATLAB, and if you use the same name, it will create problem. That's why use some unique name like say underscore or some number. Okay. So that's why this file is saved as simple underscore objective 1. Okay. So this is a M file or script file. So in that file, this is a function file. So there you write the function expression. So function y is equal to simple underscore objective 1. Then the MATLAB expression of the given problem. Okay. So y is equal to that 5 plus x by 20. No. So 5 plus x by 20. Then 5 sine 8x. So 5 sine x means 5 into you have to give. No, MATLAB expression for how to write say sine 8x. Sine bracket then 8 into x you write. Simply if you write 8x, so it will not understand the MATLAB. So the MATLAB expression of the given problem is written here. Then in the command window, simply you have to write x f value GA. Then you call that script file where the objective function is calculated. So script file is simple underscore objective 1, and the number of variable here is 1. Okay, so if you write this one and press enter, then immediately in a fraction of second we will get x is equal to some value minus 0.9903 and function value is minus 4.9652. Like this something we will get. So this type of problem you can take a problem and apply the inbuilt GA, because already the program is written. You have to understand and you can fit your problems. And next one more problem I have taken with 2 variables. If you can extend that to 2 variable, for any number of variable you can extend. Okay. Say f of x is equal to 100, then x1 square minus x is to 2 square. So there are 2 variables, x1 and x2. Okay. So in the process is same. So first create an M file or script file and save that using some unique name. So simple underscore object two say, and write the MATLAB expression of that one say. So y is equal to 100 into x of 1 square. No, then x of 2 square. So this is the way to write square in MATLAB say. Okay, that expression. Then in the command window, you simply enter x value GA and call that function at the rate simple underscore object to 2, and here the number of variable is 2. So now x will be a 2 column. Now result x is equal to minus 0.0889 or some value like this. It will give 2 values. So first is x1 and second one is x2, and the function value also we will get. Or you can use this GUI, no, the global optimization toolbox. You start, then the toolboxes, then optimization, then optim tool. Or in the MATLAB command window, the double greater than symbol will come now. Optim tool, then GA. If you write, we will get a GUI like this one. Here also you can apply the same problem can be solved in the M file, or in the command window you can write the program, or you can execute the program, or using the GUI also, the graphical user interface, using that one also you can solve the same problems. Okay. So if you see in the top it is written GA, genetic algorithm. So if you click there are many options, not only GA, like say pattern search or simulated annealing or fmin search. So many programs are available, and on the right hand side the options are given. So some options are already used default as 20, so population size. So default is 20 given. Otherwise you click that specify and change that value. Instead of 20, if you want say 50, so specify and take population size as 50. Okay. Similarly, all values are default options are given. So after giving this one, the fitness function, then there is a say here option called start. If you push the start button, then the algorithm will run. Start, you run the solver, then you view the results. In that window, you will see the results and final values. It is written here. The final, see the final points here. So the same thing you will get. Okay. Like this, the GA program is written. No. In each iteration, what is the value you are getting? You can see the earlier problem again you have applied. So from 0 to 20, if you want to search the fitness value, and this one, it will come. Okay. Similarly, the second problem, you will see that it is a difficult problem. There are many maxima and minima, and here also you can apply the GA value to find the results. What is x1 and what is x2 and what is f of x. Okay. Now we will see one more soft computing approach. So optimization technique is one approach. Other approach is multi-objective approach. Okay. So the earlier problem that we have discussed is a single objective. So that means your objective is there is a function is given, you want to minimize that one or maximize that one. So single objective optimization is when an optimization problem involves only one objective functions, and the task of finding the optimum solution is called a single objective optimization. So when I say optimization means it can be minimization or maximization depending on our requirement. Okay. For example, find out a car for me with minimum cost. So whatever car is the minimum cost, you go to the market and search. No, minimum cost, suppose a nano car is the minimum cost. Means you come out with the answer The Tata Nano is the minimum cost car. But always the practical problems are not that much simple. No, even the cost is your main criteria. We are not finding that cost. So in case of multi-objective optimization, the optimization problem involves more than one objective functions. And the task of finding one or more optimum solution is known as multi-objective optimization. So if you apply to that car problem, find out a car for me with minimum cost and maximum comfort. Okay. So not only cost, because nano car is a not that much comfort car. Suppose you want the cost should be minimum, the comfort should be maximum. So then what is the level of comfort? No, for different people, the comfort is different. No, if he is a rich man, maybe he will go for some Mercedes. No, if he is average, then he may go for middle level cars. No, like say Swift Desire or Honda City, like this one. So that means different people have got different preference. So the solution, you can reach the solution or you can take a decision when a number of solutions are available. So in case of multi-objective optimization, generally there is no single solutions. There are many solutions. And these solutions, for example, the two objective of the car in case of multi-objective is one is cost and second one is comfort. So these two objectives are conflicting. No, if you want to minimize the cost, then comfort will not be there. And if you increase the comfort, the cost will increase. So both cannot be optimized at the same time. Okay. So most of the real world problems have multiple and conflicting objectives, like purchasing computing equipment. So you want high performance and low cost. And buying a car, the cost should be minimum, luxury should be maximum, and that should be constant on safety. You should want a safe car, and should not create any pollutions. So there are many objectives. Similarly, while starting a business, we want to maximize the profit and we want to minimize the investment, minimize the risk, as well as there are some constraints like constraints on the amount, rules, and regulations. So all the problems are like this one. So they have got many objectives and they are conflicting in nature. So in case of multi-objective approach, several objectives that needs to be simultaneously satisfied. And the problem is improving the value of one objective means getting worse value for the another. Like say purchasing car, cost and performance. So both cannot be optimized at the same time. So if you want low cost, you will not get the performance. If you want high performance or comfort, then cost will increase. Okay. So one approach is select weights and aggregate the function to a single objective. Okay, you give some weight. So I want maximum say effort is given for the cost minimization. Cost is 60% and comfort is 40%. Like this, you will use the weight and aggregate that one. So, but it is difficult to select the weights. No, different people they will give different preference. Okay. Other approaches you find this is the weight. So this method is known as weighted methods. So you have got two objectives, F1 of x and F2 of x. So we use the weight W1 and W2 and find combine those two objectives. No. Now consider the problem of minimize the response time and maximize the throughput. So response time and throughput and weight values you choose. So again the problem is hard to find the values of W1 and W2 and it is hard to form a fitness functions. So second approach is determine a set of solutions that like when you are going to the market to buy a car. If a set of cars are available then easily the user, they can choose from according to their requirement. That means this type of problem already they have applied the multi-objective optimization techniques, and all the solutions are available in the market. No, our objective is buying a car, say, and solutions are different cars. So they are available in the market. So the user can go and choose according to his requirements. So that set of solution is known as Pareto optimal solution set. Okay. So the final solution of the decision maker is always a trade-off between this question parameter. So that the decision is taken after the optimization, and one can see the obtained results and choose amongst them. No, like while buying a car, we will go to the market and see all the cars, and among them what is our budget and what is our requirements. According to that, we will charge. So all population-based optimization techniques are well suited and can easily be modified to find a set of multiple solutions in a single run. So this is one approach. Some conceptual example is given, like say suppose you need to fly on a long trip. So which one you will choose? Should you choose the cheapest ticket or the shortest flying time? So quickly you want to go or you want that cost? So because again different people, they will give different say importance to this one. For some people they will say, okay, 1 or 2 hours more also does not matter to me. I will go for the cheapest ticket. But if he is in emergency condition, maybe he will choose the shortest flying times. Okay. So it is impossible to put a value on time. So these two objectives cannot be linked. Okay. Again, the relative importance will vary. No, there may be a business emergency, then you need to go and fix quickly. Or maybe you are on a very tight budget. If you are very tight budget means maybe you will choose the cheapest ticket. That means different people, they will use different. So that's why if a set of solutions are available, then you can choose the best ones. Again, this is some example I have taken. This part I will skip. Okay. So this is one more approach. That is, either you can apply a single objective approach or you can apply a multi-objective approach. Okay. So this is one approach. Next sub-computing technique is the fuzzy logic. So fuzzy logic, that is, if you can understand the precision versus significance. So in science and engineering, there is a deep-seated tradition of giving much respect to numbers than to words. Okay. But the problem is, as the complexity rises, meaningful sentences lose precision and precise statements lose meaning. Now, for example, precise means accurately correct. So if you want to measure weight, so let us say Vinod's weight is 91.982791. So that is the accurate, means precise statement. So if you ask what is your weight, and Vinod says that my weight is 91.982791, then people will think he is mad, even though he is telling the exact answer. No. So simply if you say Vinod is overweight, so it will carry more meaning. No. Similarly for height, if Rama's height is say 6.1025412 feet, so even though it is a accurate sentence, no, precisely he is telling his height, but people will find him funny. No, but instead of that one, if you say Rama is tall, so automatically you will see that okay, his height is about 6 feet or slightly more than 6 feet. Okay. So that means sometimes words carry more meaning than the figures. So even though figure means the numbers, even though the numbers are more precise, but sometimes words, they carry more meaning. Okay. Like precision and significance. Like suppose you are standing in a factory and a mass is coming. So a precise statement will be like say 1,500 kg mass is approaching your head at 45.3 meters per second. So this is the precise. What is the weight of that mass is coming and at what speed it is coming. So if you try to explain your friend who is in danger, then by that time he understands probably that mass will fall on his head. Simply if you say look out or move away, so maybe he will be saved. So that means it is better to be approximately right than precisely wrong. So sometimes words carry more meaning. So based on this one, the fuzzy logic is designed, fuzzy logic controls. Like controlling a fan. So in a conventional mode, how to control? You are controlling the fan speed. If the temperature is greater than 24 degree, you run the fan. Else, stop the fan. So either yes or no, conventional modes. So in fuzzy system, we write the program using if then statements. Like if temperature is hot, you run the fan at full speed. If the temperature is warm, run the fan at moderate speed. Then if the temperature is comfortable, maintain the fan speed. No, if the temperature is cool, slow. Or if the temperature is cold, you stop. So instead of the 24 degree, you are using the watts: hot, warm, comfortable, cool, or cold. You can understand better by using one more example, say fuzzy logic control system. So to understand the fuzzy logic concept, first you should understand the set concept, fuzzy set. So before that, the classical set. No. So classical set is a container that wholly includes or wholly excludes any given element. So this is an element will be either in the set or not in it. No, because there are so many elements like shoe, police, butter, Monday, Thursday, liberty. And if you want, what is the days of the week? So Monday, Thursday, and Saturday will be in that set. All other things will not be in that set. If we apply to some other people, the same concept to set of tall people. There are many peoples are there. Say. So tall people means in case of conventional set, you will specify a number. No, like when you appear for the exam, say 35 is the pass mark. So that number is 35. Similarly, when you say tall people, say if he or she is 180 centimeter or more than tall. Say. The short people means the shorter than 180 centimeters. So if there are many people, suppose 180 centimeter, 200 or 250 centimeter, so all they will be the member of this set of tall people. And at the same time, whoever is less than 180, like say 100 centimeter or 150 centimeter or even 177.999 also will be a short. No, because as per our definition, if his height is less than 180, he will be short. Okay. But it looks odd now. If you say a 100 centimeter person and 179.99, they both belong to the same category, even though the difference is around 79.99. But the difference between 179.99 and 180 is 0.0001. But 180 is coming on different sets. No. So to human reasoning, it looks odd. No. So if you use the watts instead of this number, then it will be more meaningful. Okay. That short, like this one, I will take here. So instead of this one, if you define almost tall or very tall, okay, I have taken one example. Say. So based on this one, fuzzy logic works. Okay. Fuzzy Okay, next is we will take a problem. Okay, in the fuzzy. Okay, where is fuzzy logic? Okay. So classical set and fuzzy set. So if you use one more example here, say, to understand the concept of fuzzy logic. Okay. So the days of the week, no, nowadays, if you see, the government has ordered that Saturday and Sundays are holidays and remaining days are working days. So classical set, if you want to find the set of weekend days, means when they are the holiday. So Saturday and Sunday are holidays. So Saturday and Sunday holiday and Monday to Friday are working day. So if you see in say classical set, the days of weekend means only Saturday and Sunday will come, and working days means Monday to Friday they will come under the set of working days. But if you apply your human reasoning, so because Saturday and Sunday are say holiday, in the Friday evening probably you will enjoy more. No, even though the Friday is a working day, but Friday evening you will be full of say in a relaxed mood because the next 2 days are a holiday. So you will say that Friday is not fully working day. It is partially working day and partially it is say holiday. Similarly, Sunday, even though the Sunday is a holiday, but Sunday evening or Sunday night you will be in tension because the next day you have to get up early and go to your job. So even though Sunday is a full Sunday is a holiday, but still it is not fully. So this fuzzy concept is based on this idea. So it allowed a degree to certain degree it is holiday, not fully. So if you use Saturday, maybe Saturday is fully it is holiday. Like this you can say think of this one. Okay. If you use the crisp set, if you put a question, you use 1 or 0. No, 1 is true and 0 is false. So is Saturday weekend day? 1 is yes. And is Tuesday weekend day? No, 0. But if you use the fuzzy logic, so it permits in between values. Like if Friday a weekend day, so Friday maybe instead of 1 we will assign a value of 0.8. So that is the degree. That means for most part it is working, but not completely. Okay. Like each Sunday weekend day, 0.95 value we will assign. Instead of 1 and 0, in between values we will have. So that means almost it is a holiday or nearly holiday. Some words we will use. So this is known as degree of membership functions. What is a membership function? So membership function is a curve that defines how each point in the input space is mapped to a membership value or degree of membership between 0 to 1. So between 0 to 1, just some concept like our set of 12 people. No. So we use instead of a crisp, no, if you use the first figure, you can see that suddenly it jumps from the 0 to 1. No, either people will be in 0 category or 1 category. But here in between it is allowed in case of fuzzy logic. Different sets you can use to define these membership functions. Okay, you can use some other concepts also. Okay, so based on this one, the fuzzy logic system will work. So final value will be again crisp value. So you will give input the crisp values. Then the fuzzifier means it will change these numbers into words, and there will be rules, fuzzy rules, and based on fuzzy inference engineering, you will get again finally the crisp values. Okay. We have taken one example, then engineering example, like a simple system, AVR system, automatic voltage regulator system. So this is nothing but a transfer function. Okay. So because you are all branches, so this part we will omit. We will come to that the model. No, if you take any system, so it will have some plant transfer function. No, so it has got an amplifier, exciter, and generator. So they are represented by, let's say, a sensor, say, the transfer functions. And the time domain response of that system, which is uncontrolled system, is given. Say. So the dot values are this rise time, maximum overshoot, then settling time, and steady state error. Okay, so these values. So if you can see that the response is oscillated now, and our objective is to design a controller for this problem, and then use some optimization technique to solve that one. Say. Okay, so you will use a PID controller. Say. So now the PID controller has got the parameter Kp, Ki, and Kd. So those parameters can be searched using some like our genetic algorithm, as I said at the beginning. So you can apply the genetic algorithm to search those optimal controller parameters. Okay. So PID controller will be having a proportional action, integral action, and derivative action, and these parameters can be searched by some techniques. Okay. So if you are using the MATLAB, the first is you have to develop the transfer function model with PID and without PID. Okay, the lower one is without PID. So all the values are given. No, the exciter, generator, sensor, everything. But the top one is a PID controller is connected. Now you have to first, if you want to apply the optimization technique, as you have discussed at the beginning, first is you have to define the objective function. So what is your objective? Your objective is the final response should be an acceptable one. Here you are getting a response like this one. There are oscillations and it takes a large time. No, that means in case of control system, we say that the time domain response should be better. So how to specify the time domain response? You can use some integral error criteria. Those who have studied the control system, they might have studied. No, like say integral errors are generally used. What is those error? Like say ITA, integral time. So those errors you can construct here. So objective function you have to specify. Like ITA, integral of time multiplied by absolute value of error, or ISC, integral squared error, or ITSC, integral time multiplied by squared error, or you can create all your own error criteria. Because if you want to apply any optimization technique, first you have to define the objective. What is your objective? So from that model you find the error. So, error is reference minus actual, and find the ITA value of that error, or ISC value, or ITSC value, or any other as per your requirement you can write. Then the same GA you can apply. Okay. For that, first you have to write. First we will see this one. The like our simple underscore objective, or simple underscore objective 1 and simple underscore objective 2. No, two objective functions we have written. So first step is you first write the objective function as a function file. So write function y is equal to AVR underscore objective x. No, and you define the variables as global. Global is Kp, Ki, Kd. So Kp, Ki, Kd is that controller parameter, PID parameter. So Kp is x of 1, Ki is x of 2, Kd is x of 3. Then the simulate that model, sim bracket AVR underscore PID 20. That means sim means we are giving sim command. So from the MATLAB command window. So if you execute this line, that means the model will be simulated. And the name of the model is AVR underscore PID. So that means this model is AVR, you have saved using the name AVR underscore PID. Okay. Then Y is equal to max of ITAE or IAE or ISC. To as per your requirement, you can write. So this is first is to use to optimize any objective function. First, you have to create a file where objective function is calculated and save that file using some unique name. Here I have saved as ABR underscore objective. Okay. So that will be called here. Next is you write the program. Not program, simply some commands, because already the program is written. Okay. And that program is saved using a function file GA. Okay. So what I have done here is CLC, means it will clear, then clear all the variables. Then the fitness function is defined. No, is with the function handle ABR underscore objective. So you see that in the next slide it is given. No, ABR underscore objective is the objective function where all these things are written. Then you define those variables as global variable KP, KI, KD, and n bars. N bar is the number of variables. So you have taken number of variables as 3. No, because KP, KI, and KD. And then LB and UB. LB is the lower bound, UB is the upper bound. So these are specified. Depending on your requirement, you can specify. So in this particular problem, all the lower bounds are taken as -1, -1, -1, -1, and UB is the upper bound. So that is taken as 1, 1, 1. Okay. Then, as I said, if you run the GA program, so it will use some default options like what is the generations. So default generation will be some 1000, and similarly population. Default population may be something. So if you want to change that one, you can, in the program itself, you can change that one. So option is equal to GA optim set generation is 20. That means you are setting generation as 20 by using these commands. Okay. Similarly, runs 10. So runs 10 means it will run 10 times, because all optimization techniques, they're the initial solution is generated randomly. So, and based on the initial solution, the algorithm will evolve. So we do not know how good the initial solutions are. And depending on these initial solution, the algorithm will evolve. No. So that's why generally all these population-based heuristic means where probability is involved. No, because initial solution may be good or may not be good. If the initial solutions are good, so very quickly we'll get the better solutions. If the initial solutions are not good, probably it will take more time, or you may not reach the best solutions. So that's why it is applied many number of times. So here it is given as runs is equal to 10 means the same technique will be run 10 times, and the best result obtained in that 10 runs will be taken as your final, say, controller parameters. Okay. So you are using a for loop here. For m is equal to 1 to runs. That means first up to number of runs is 10. You are calling that same x f value is equal to GA. Then the fitness function and the lower bound, upper bound, those options are given. So after running that one, you are storing the value, no, KP, KI, and KD values. And you can use the print command, fprint, to print in the command windows. Okay. So if you are applied multiple times, you can collect the minimum value, maximum value, average value, and standard deviation value of those results. Or you can find other analysis also, you can do so, like minimum damping ratio, eigenvalues, and do the analysis. Okay. This is the model here. Those errors are calculated here now. Okay. The ISC error, ITA error, IAE error, or ITSC. So error is the reference. Reference is 1. Actually, you are calculating. So reference minus actual, and that error either ISC or ITAE or IAE will we are calculating. Okay, so this is one approach. Any controller parameter you can tune or optimize using the optimization technique. And to begin with, the inbuilt optimization technique of MATLAB you can use. Okay. Next is, now this part is little bit now research oriented. Okay. Next is improved and hybrid optimization technique. Because nowadays, in most cases, if you want to publish the papers, you should have your own contribution. No, if those techniques are available, and simply if you apply those techniques, probably no one will accept. No, the journal will not accept your paper. They will ask, what is your contribution? So you have to introduce some improvement from your side. Like you can improve the optimization technique, or you can improve the controller structure. Okay. So as per no free-lunch theorem, there is no meta-heuristic method which is well suited for all type of problems. So we cannot tell that this technique is the best. So all the techniques depends on the type of problem. Okay. And every heuristic algorithm has its own advantage and disadvantage. So that's why if you use a hybrid algorithm by integrating two or more algorithms, which are now recently proposed in literature, to take the advantages of two or more algorithms. Okay, so actually, if any optimization technique, then there are two stages. One is called exploitation stage, and second one is called exploration stage. Exploit means nearby areas it will search. Explore means it will search a large area. So all the optimization techniques should have these two capabilities. It should be able to explore as well as exploit. Okay. So a global search method explores the wide search space, and a local search method generally search the local areas. Okay. So these two are conflicting. Explore the search space and exploitation of the best solutions found are the two contradictory criteria that must be taken into account when designing or using a meta-heuristic. Okay. And a good balance between these two will enhance the performance of the searching engines. So I have tried to propose some improved techniques. Okay. Let us start with the simple techniques like sine cosine algorithm. So this is a recent technique, and here the base of this technique is it will update the position in the next solution depending on the current solution. So this technique is only two-line solution actually. Okay. And already the author who has proposed this algorithm, sine cosine algorithm, he has compared the result with PSO, GA, BAT, then FPA, Flavor pollination algorithm, Firefly algorithm, and gravitational search. And he has taken a set of problems. For those problems, SCA, he has demonstrated that SCA is working or giving better result than this PSO, GA, BA, FPA like this ones. But for all the problem, it may not be true. But for those considered a problem, SCA is giving better results. Okay. So this technique is very simple. It follows, it generates some random numbers, like say R1, R2, R3, and R4. And based on that one, simply the position is changed based on a sine term or cosine terms. Only two equations are there. And these parameters are varied in a particular manner. So if you want to improve or modify that one, to try to vary that in a different methods. So for example, in first case, R1 is varied as A minus T, A by T. Okay, where A is equal to 2 and T is the current and maximum solutions. So if you want to vary that in a different manner, R1 is varied as a 1 minus T3, T2 power 3, 1 by T2 power 3. So in the figure, if you see, it will be more clear. So R1 in SCA, so that is varied randomly between 2 to 0. No, not randomly, linearly. If you see R1, first one, R1 SC. So it starts from 2 and reaches 0 value by 500, last iteration, 500 iteration. But improved technique, R1 is varying using that black ones. So initially, slowly it is decreasing and rapidly towards the end of the iterations. So in first case, original sine cosine, linearly it is decreasing, but you can modify that using some other equation where initially slowly it is decreasing and rapidly towards the end. Similarly, other parameter R3. So R3 is the random parameter between 0 to 2, and that is varying from 0 to 2. And in the modification, that blue one, how it is varying randomly with a decreasing index. So randomly it is varying from 0 to 1, but gradually decreasing. So if you do some modification, you have to test that one. So how to test that one? There are some test functions or benchmark functions, and they are classified as unimodal functions, like say this one, F1, F2, F3. Some expressions are given. For this, already the known value, F minimum value is known. F of F minimum is equal to 0. For example, first one, first, second, third, all are 0. That means if you apply your technique and it's giving 0 or close to 0 value, that means your technique is working fine. So that's why whenever a new technique is applied or proposed, first they have to test on these test functions. So this is the set of unimodal test functions. Next is the multimodal test function. Multimodal means it has got more than one maxima or minima. Then like this, if you see the space like this one, this is the unimodal functions. So only one maxima or minima. Next, if you see this is one maxima and minimum. Multimodal means like this one. There are many maxima and minimum values. Okay. So how to implement this ISC algorithm? So because this is very short algorithm, so define the bounds LB and UB, lower bound and upper bound, and dimension you have specified, and write the MATLAB expression. The same thing what you have done. So function O is equal to F1 of X, O is equal to sum of X square. Then you do the initialization. So the solutions are generated. So between the lower bound and upper bound, then you use the algorithm. While T is equal to the maximum iteration, you find the value of R1. You see that in the R1 you are changing. So originally it is given as red, and you modified that one using a new equation. And similarly R3 also originally it is 2 into red. That means randomly it is varying from 2, 0 to 2, and R3 you are using some other to red. So because R1 is changing from 0 to maximum to 0, and if you multiply that one here, so obviously it will also reduce to 0. So main is, this is only 2 line. Main equation is, you can see that here in the last 2 line. One is sine term and second one is cos term. So based on sine and cosine it will work. So as I said again, the number of search agents, iteration, and number of runs here again multiple times you have to, because all the solutions are randomly generated. No. So if you apply and get some results, so that results may not be valid all the times. So that's why this type of problem means the heuristic search technique, where initial solutions are randomly generated, multiple times you have to apply the problem, or you have to execute and get the result. So here the number of runs is taken as 30. So then in a loop, for loop, we are putting that one. I is equal to 1 to number of runs, and ISA you are calling here. So applying this one, you collect the best average, worst, and standard deviation, and that is reported in the table. Okay. So for different dimension, 5 dimension, 10 dimension, and 20 dimension, and 30 dimension. So always, if you are doing some modification, you compare with the original one. So only one I can explain here. Say, like say for first result, F1, the first column is for ISCA. So it is giving 2.46 into 10 to power minus 86. And next is SCA, 0.09 into 10 to power minus 29. So the best solution is 0. So whichever solution or whichever technique gives close to 0 value, that will be better. So one is giving 10 to power minus 29, and second one is 10 to power minus 86. So obviously 10 to power minus 86 is closer to 0 compared to 10 to power 29. So like this, you can justify that the improved technique is giving better than the original technique. So for all the cases, for next is 10 dimension also you can see. So here it is giving 10 to power minus 57, and original sine cosine is giving 10 to power minus 9. Okay. So in majority of the cases, it should give better result. Similarly, we can compare with some other published results. So ISA is compared with PSO and GSA and GW. So those results also you can compare. So your technique should give better result in most of the cases, if not all. So for some one or two cases, it may not give, because a particular problem technique may work in a better way for a particular problem. For example, you can see F6, our ISA is giving 5 point something, whereas GW is giving 0.8. So obviously GW is better in this case compared to ISA. Or PSO is giving still less, 0.0001. Okay. So for a particular technique, a particular problem, a particular technique may give better results. But if you see overall, for majority, your technique should give better results. Then only it will be accepted. Similarly, the analysis for multimodal test functions. So here also 5 dimension, 10 dimension, 20 dimension, and 30 dimensions are taken. Yes. Okay. Next is similarly one more technique, that GW is taken. And how to modify this one? This is the original GW. Those who are working in GW, they can understand again. So GW, different wolves are used. You know, here gray wolves, like say alpha, beta, and delta. And based on this position, it is changed. Okay. So here also some modifications are introduced here. In the original GW, what is done? Parameter is decreasing from 2 to 0, and in the improved GW, that is varied in a different manner. And in the original GW, the position vector of a gray wolf is guided by these 3 wolves: alpha, beta, and delta. Those who are working in GW, they can understand this one. Alpha is the fittest. Next best is beta. Next best category is the delta. So they are arranged in this order. And equal importance is given. That's why in the original, the left-hand equation, x1, x2, x3 by 3, average of that one, it is calculated. So in the improved version of this one, more weightage is given to alpha, because alpha is the fittest one. So whoever is fittest, more weightage is given to that one. So 2 into x1 followed by beta. And delta is neglected because delta is the least fit. So that is removed in the or say modified versions. So left hand equation x is x of t plus 1 means in the next iteration what is the value x1 plus x2 plus x3 by 3. So that is replaced by 2x1 plus x2. That means x3 is neglected. X3 is that delta. So simply if you change, it will not justify. You have to compare, like previous case, you have compared with the PSO, GSA, D, where in many cases the results are available in the papers. And you can compare your original and improved. Okay. So because you are neglecting one step, here we will get that education time also improves. No, using TikTok command, you can find the education time. So for F1, you can see that the time taken is 3.83. And for GW, it takes 4 point something. So around 16% improvement is there. Okay, time in second. So similarly for F2, if original GW takes 5.13 second and improved GW taking only 4.09 second. So almost 20% improvement is there. So in less time you are getting the better result. So that is the objective of this study set. Okay. Next is hybrid. So you can combine two optimization. One way of getting better result is you can improve in the original technique. You change some equations, so you will get the better result. Other is you use two or more than two techniques. Okay. So the best way is use a global search technique and use a local search technique. So again, as per the no pre-lunch theorem, no meta-heuristic method is well suited for all problems, and there is scope for improvement. And every heuristic algorithm has its own advantage and disadvantage. So these hybrid algorithms, by integrating two or more algorithms, they have been recently proposed in literature to take the advantage of two or more algorithms. So the key to achieving high performance for any meta-heuristic algorithm is maintain a good balance between exploitation and explorations. So global and local search techniques. This I think already I said. Okay. So how to combine? Okay. So there are different again approaches. So one is the low level hybridization and second one is high level hybridization. Okay. So one of the meta-heuristic hybridization model is to combine a meta-heuristic with a complementary. Okay, complementary means if one is following a set of rule, the second one is some different rule, contradictory rule it is following. Okay. So in the low level hybridization, a given function is replaced with another equation. That means inside that there will be a main algorithm, but one or two equations are modified based on some other algorithms. So that is known as low level hybridization. And second approach is high level hybridizations. So here the algorithms are executed in sequence. So first you are applying a particular technique, next you are applying a second technique. So that is known as already also known as the relay hybridizations. Okay. One example I have given. Use the improved well optimization algorithm and simulated annealing. So these are the two techniques, well and simulated. So these two can be used to build a new hybrid algorithm. So the first is IWA. So that is the global search method. So that will explore the wide search space. And second one is the local search, which is simulated annealing, that will exploit the local search. So both these capabilities should be there, explore and exploit. Okay. So there are many local search techniques like simulated annealing, And second one is pattern search. So all these things are available in the MATLAB. You can utilize. And how it works, just now I have collected here, say, local search, or one more technique is hill climbing, or local unimodal search. Okay, so these techniques can be applied. And you can see that nowadays, some recent publications I am showing, you can see that if you employ some this hybrid or improved technique, then only the chances of publications are more. Either you have to introduce novelty in the controller or in the techniques. Say, for example, in the first, it is adaptive differential evaluation. That means D technique is the original technique, and by changing some equation, it is made adaptive. And similarly, you can introduce some newness in the controller also, like hybrid fuzzy PDPI. So fuzzy logic and PID controllers are hybridized. And these controller parameters are obtained using an adaptive differential evaluations. Okay. Similarly, second paper, if you see modified well optimization. So the original the well optimization is modified using some modified equations. Okay. The third one is also modified well optimizations. Then GWO and CSA is hybridized, or SALP swarm optimized. So improved, I mean that technique is improved. And last one, if you can see, differential evolution and particle swarm. So these two are hybridized. So nowadays, if you want to publish the paper, either you have to use some improved technique or hybrid technique, and then only, and you have to justify also. You do the multiple runs and compare the results based on your average and standard deviation value. Then only you can justify that, okay, something new you have proposed. Okay. Any queries? You can ask now. Manas, are you there?
Thank you very much, sir. Now we'll start our question session.
Okay.
Now request all the participants, please raise hands so that we can unmute yourself and you can answer you can ask your question directly. Otherwise, you can write your questions in the chat box so that I can also read those questions. And the sir is now to answer to all your questions. Sir, one question is there from Sasmita Naik. What is full form of GWO?
Yes, what is?
What is full form of GWO? A question from
Okay, GWO is gray wolf optimization. That is an optimization technique. Like GA means genetic algorithm we are using.
sir.
GWO is a new optimization technique. Gray wolf optimization.
Sir. Next question, please. Dear participants, you can raise hands. Otherwise, you can write your questions in the chat box also. Raise hand question. Unmute kar do. Next one. Jono karo. Biresh Thakur, sir, you can ask your question. Biresh Thakur, sir, you can ask your question now. Biresh Thakur, sir, you can ask your question now. Shriram. Next, Shriram, sir, you can ask your question.
Sir, very good morning to both of you, sir. Sir, I have written a thesis, my past thesis degree in algorithms, traveling salesman problem. That is a hard problem. now I solved it using exact methods, new exact method or type of. First, I started with one approximate solution for that, but later on I was got time. So because my thesis was extended for 1 more year, so for MTech I solved it using exact method. I want to now solve it with one heuristic method for a traveling salesman problem. So that one is a kind of a hard problem, right, sir? So,
Yes, yes.
sir, I want one method which will be a better method like GA, like
No,
SA.
no. Okay, to begin with, you can apply your GA method. Okay, because GA, you need not write the program. Program is available in the MATLAB. Okay. So at least you applied some conventional method, hard method or something what you're telling. That result and this GA result you can compare. Okay.
Okay. Okay. So it will be in heuristic for traveling salesman problem. One of the
Oh, yes,
easy.
it is applicable. I have seen many problem optimization techniques have been applied to traveling salesman problems. Even if you search the net, directly you will get the code for this one, solving traveling salesman problem
Uh,
by using optimization technique.
uh,
Okay.
is there any way to convert any exact methods to heuristic methods? Like I have developed one exact method of.
Exact. Okay. Heuristic method you can compare with your set that exact method. Okay.
Yeah. Okay, sure,
Many
sure.
methods you simply search in the MATLAB in the web, you directly will get the codes. Okay.
Oh,
Traveling salesman problem is solved by some
yeah,
optimization
sure,
technique.
sir.
Okay.
Sure, sir. I will do that. Thank
Okay.
you very much, sir.
Next question. Next question, please. Raise hand question. Prakash. Prakash sir. देखो present किया है। Okay. Any more question, please? Sir, there is one more question. For task allocation of robot, which method is better to use?
Again, as I said, beforehand you cannot tell which method is better. You to all the techniques are problem dependent. For a particular problem, a particular technique may work in a better way. So anyway, best way is you apply 2-3 techniques. Then you will find out which technique is better.
Yes.
And okay, so that is the best approach. You apply more than one technique.
Yes, sir.
Standard. Then you can identify, you can at least get some conclusion that this is the best approach technique for this problem. Okay.
Avnish Priyadarshi. Avnish Priyadarshi, sir. You can ask your question, sir.
Hello.
Yes.
You can ask your question, sir.
Namaskar, sir.
Namaskar. Kun.
Sir Prakash. Here, Prakash, sir.
Prakash.
Sir, is it necessary in each and every step? There should be a proper balance between exploitation and exploration to improve the performance of the optimization technique.
No, if there is no balance, the optimization technique will not give the satisfactory result. Okay. There should be any algorithm, there should be balance. Otherwise, it will give emphasis only to only exploration. Means nearby area it will not search. It will search only the wide areas. Okay. And
sir, second question, sir. Sir, we have two optimization techniques. One optimization technique use time for accessing the parameter of the controller. But whichever is taking huge time, it gives better performance. Means its optimization parameter is better.
Okay.
But to that case, we'll consider which optimization technique is better. One is taking less time, but it gives parameter not so much accurate as compared to other optimization technique.
Okay, that depends on the problem. If it is offline work, time is not important to you. Okay, so whichever technique is giving better result, that is the best approach. But if it is online, where time is important, then in quick time, which one you are getting, that is important. Okay, so that is depend on what is the application your problem, offline work or online work. Offline means time is immaterial. Your solution should be best one. Okay,
Yes, sir.
like our load flow analysis, you apply Newton Raphson and say fast decoupled. No, Newton Raphson will be accurate, but it will take more time.
More time.
Fast decoupled very quickly will get. Okay.
Sir, thank you, sir. Namaskar, sir.
Namaste.
Next question, please. Biresh Takwa, sir, you can ask your question. Biresh Takwa, sir. Next question, please. Okay, you can. No more question. Any more questions from the participant side? Okay. Okay. So thank you very much, sir, for your informative talk. I am very sure this talk will be helpful to all our participants in the implementation of soft computing techniques and their applications to various engineering applications. We all have learned a very recent techniques about this computational methods and its applications. Thank you very much, sir.
Okay, you are welcome.
Dear participant, now we are going to share attendance com feedback link. Dear participants, we have shared attendance com feedback link now.